Okay. I don't know why that happens. My headphones just occasionally disconnect from my computer. I'm thinking about getting a card that just does Bluetooth and has like some antennas on the back or something. And then it reconnects. Watch. See, now it's connected and then I can play the music again. It's just so weird. I mean, the fact that it says IT decides to upgrade sort of implies that a plan of action was already created. But maybe a plan of action is like talking specifically about what you're going to be doing. But if you've decided, like, do you decide something and then make a plan of action, or is it like the other way around? I'm gonna go for 3. Okay. A T carrier system. So this isn't used anymore. Okay, so it's like a way of transmitting phone calls. I just need to remember that T carrier is a phone call thing. Why would it be 4? Port address translation? Another term for port address translation. Really? Isn't port address translation just you have something running on a port on a local node, and then when it hits the router, it does, not only does it do network address translation, but it also does port address translation. As in, it makes it so the port that this is silly. I could be wrong. I'm gonna channel my inner pirate software here. Dude, this is so shitty. I'm getting a new mouse soon. How do I... Dude, what? Dude. It should never be like... I hate this mouse, dude. There we go. Zoom out. Oh. Whoa. Okay, there we go. So, as far as I know, the way it works, right, is you have this computer, right? Let me zoom out a little more. Well, dude, I'm just gonna get a new mouse. Hold on. Literally anything is better than this. Can I do this? Does this work? Hello? Yes, it does work. Great. Okay. Use this bad, like, what brand even is this? Targus. I'm gonna use this Targus wired mouse. Because it's better than... Oh, dude, functional scroll. Oh, finally. Oh, this is so nice, dude. Let me turn down the sensitivity a tiny bit. ID 12. That's a little low. Hold on. Can we do 0.7? If I move this mouse, do you see that? If I move this mouse too fast, it like... Bro, okay, that's still better than before, frankly. Yeah, so say you have this compute. What is happening? Oh my god. Oh my god. This is torture. Okay. Okay, so you have this computer here, right? And it's running on like x.x.x.x, right? And it's doing let's do port 443, right? It's running a HTTPS like web server, right? So it goes to you know, this router, right? Right? And the thing that happens is it translates this port like into its. This looks like a transistor or something. It translates its port into its own port, right? Well, I mean, it's probably actually going to like a ISP thing, and it does like the actual external IP. But you know, for the sake of this, let's do like 192. Let's say it has like its own static IP address, right? What's like a, hold on. Yeah, so like, right, so you have this IP, right, and it's the public IP, but then it also does the port translation into like, I don't know, like 809 or something, right? So then computers try to connect to this thing, it goes to the router, and then from the router it goes to here, right? I could be way off. Let me look at my notes and see if I have anything regarding PAT. Or yeah, no, not OBS. Obsidian. They both start with OBS, and so sometimes I accidentally try to open OBS. So port. Oh, okay. And what did I get wrong? NAT overloading. Wait, let me try and think of why. Okay, so network address port translation, also known as NAPT, also known as port address translation, is a solution for when network address translation must translate different packets from nodes on the LAN to different nodes on the WAN simultaneously. In the case of accessing a website with HTTPS on the internet, when a node tries to access the web server with port 443, in addition to translating the node's local IP address to the router's IP address, it also assigns a unique outbound port to the communication to ensure inbound packets destined to that particular local node are correctly routed. Sure. Okay, wait. Let me not read this. Okay. The thing I got wrong here is that ICE was sort of doing it in reverse. So like, there's a thing here on port 443, and when it goes to the router, it actually, you know, to communicate with like multiple devices on the network, it needs to turn this into multiple ports when interacting with, or like when these computers are interacting with the router to like communicate with this web server. This should be 443. To interact with this web server, it needs to have multiple different ports from the same IP address. Okay, you're on the right track. You've got the mechanism right, but the term overloading refers to the IP address itself. Think of it this way: you have one public IP address, but you're forcing it to do the work of many internal private IP addresses. You're literally overloading that single public identity with the traffic of almost an entire network. Or you mentioned about using multiple outbound ports is how the router pulls this off. Since the packet looks like it's coming from the same public IP, the router uses the unique port numbers to keep track of which conversation belongs to which internal device. Without these unique ports, the replies would come back to the router and wouldn't have a clue which computer on the LAN actually asked for the data. So Pat describes a method in NAT overloading, describes a relationship. Sure. I know 3 Pro isn't the best large language model according to artificial analysis in regard to intelligence, but it's still like half the price of like 4.5 Opus and like GPT 5.2 extra high. And GPT 5.2 extra high, it takes like 40 seconds to answer a question. Right. Time to live. It's very funny because it refers to the maximum number of hops. So I guess that'd be 1, yeah. The role of router advertisements. I don't think it's 1. I don't think it's 3. I feel like 4, yeah. The T carrier system. Voice traffic digitization. And then that would be overloading because there's synonyms. Squeezing the tea bag out. You want to revise the access control strategy to a more secure model. Which access control model should you advocate for to ensure that access to sensitive project files is strictly controlled? That be mandatory access control? Oh, dude, this one. Fuck. Okay, it definitely goes higher. Okay, all of them go higher. I think public addresses can start with 196, and I'm pretty sure Class B is only for like research purposes. But I could be wrong. I could be thinking of like Class E or something, like a 210 and above or something. 124 and 131 seem close to each other, but not as close, because that's a 7. That's a 7 number gap, as opposed to the 6 number gap, the bottom two. Okay. Okay, it's not 1, it's not 4. I feel like it's either 2 or 3, because, you know, 131 and 190 are far away from each other enough, I feel, that it's unlikely they're in the same class. I could be wrong, but I don't. So, but because of that, I don't think it's 1 or 4. So I feel like it's either 2 or 3. It's either A, B, C, C, or B, B, C, C. I'm gonna go for 3. I could be off. I could be wrong. Okay, it was 4. I just need to learn. Like, I just need to learn IP address classes. Convergence problems. I mean, that's the only one that's a real problem. It's not 2. Analyzer, moderator stands, sound filters, antenna, satellite, dog, dog cam, cat tree, cat this. Could be multicast. A, B, B, C. Best describes the role of a sniffer in an IDS. which server? The remote server? Yeah, I guess web apps. Okay, yeah, we're a remote server. Okay. What can you infer about the network condition? With varying RTT times. I mean, would you get, if there's packet loss, return trip time? I don't know, I feel like it might be 1. Okay, yeah. This is the broadcast address. Because the cider block is 16, not 24, or 8, right? I mean, it should be Wi-Fi 6 because it's newer, but 1 makes no sense, so it's got to be 3. That's kind of a shame of a question. It's a shameful question, respectfully. Disrespectfully. Disrespectfully, that's a shameful question. Voting with many other businesses, best possible performance. This song is so good, dude. Manipulate spanning tree protocol. Okay, that makes sense. ACE. I remember getting that one before. I don't know why I didn't remember when I was answering the question initially. Time division multiplexing, PBX versus a voice over IP PBX. What is it, PBX? Point base exchange? PBX. Private branch exchange. VoIP is kind of software, so that's what made me think that. What? Oh, I guess that makes sense. Okay, great. I'm going to use the restroom for a minute. Be right back. I didn't unmute my mic. Sorry. Sure. Okay. With terminal emulator software. Guys, check out my terminal emulator software. Isn't this sick? Wow, terminal emulator. To configure the router before it can be connected to the company's network. It's not one. It's not two. What? Really? I guess it's not connected to the company's network, so you can't really... What? That's crazy. Bro. That's really funny. What? This didn't look like this morning. They just changed this, I think. I'm actually, you know what, in a router configuration, I'm probably going to network hardware. Router. Wow, 60,000 kilobytes, you can barely even tell. It's incredible, honestly. I do this. It looks like I've already sort of mentioned this. Cool. Okay, that ringing is my ears, not the music. Or is it the headphones? It seems like it's the headphones, but it could just be more noticeable because I have noise cancellation on. If the noise cancellation's off and it's less noticeable. R use. Whoopsie daisy. Because it's something you know and something you have. Those are the two factors. Is there like a... I should just learn more about IPv6.
Let's learn some IPv6 basics. First of all, binary conversion. Here's an IPv4 address, 32 bits, converted into binary here, and then the subnet mask converted into binary here. /24, and then 24 ones and 8 zeros, and then the octets here, the 192 octet, 8 bits here, and so we have 4 octets. Now, in contrast, an IPv6 address is 128 bits, and the characters are hexadecimal characters. So each character is 4 bits, and we call these hextets. So you have 4 characters in a hextet, another hextet, so there's 8 hextets, 128 bits. And here's what it looks like if you convert it to binary, and I've put a dash here to identify each character. So this is the 2 right here, and then the 0 here, and the 0, and then the 1. So just this right here is the first hextet. All right, let's look at the next slide. IPv6, 128-bit address, colon-separated hexadecimal notation, 8 hextets. On every interface, you need a link local address on each interface. Now, the link local address is locally significant only. It's not routable to another. Network. It's not routable on the internet. You can only use it or communicate to it on the.
What did I get wrong that made me? Well, first, hold on. Preamble on SFD. On the local link, which means the local network. You can have multiple routable addresses on each interface. So each interface can have multiple routable IPv6 addresses, and there's different types. There's a global unicast address. Now this is a unicast address that you could put on your interface, on your router, or on your PC, and it's routable on the internet. It's basically the equivalent of a public IPv4 address. Global unicast address would be like a public routable IPv6 address. Now, a unique local address is also unicast. It's for a host, just like a global unicast. A unique local is for a host. However, it's a private address. So it's similar to an IPv4 private address. Now, we don't actually really need these in IPv6 because IPv6 address space is so huge that every device in the world, if they had an IPv6 address, we could have all public addresses easily, 10 times over, 100 times over, all the devices in the world could have a unique public IPv6 address. However, since a lot of network admins are used to having private addresses that are only routable on a private network, they came up with unique local addresses that are private. Okay, there's anycast addresses. An anycast address is the same as a unicast address, but you can assign the anycast address to multiple devices. In other words, you could have 3 routers with the same address, and then it would be an anycast address. You could configure it as an Also, I'm going to ask Opus.
as an anycast address. And then if you want to reach the router, you would reach the nearest device, basically the first device to respond. And that's anycast. So same address on multiple devices, and then the nearest one responds. In IPv6, we don't have any broadcast addresses. No broadcast addresses, only multicast addresses. And multicast addresses are similar to broadcasts in a way because they get sent out to multiple devices on a network. So we use multicast addresses instead of broadcast. Then each IPv6 address will have a / network prefix. It's in a / decimal notation. So when you see /64, this 64 is actually in decimal. It means that there's 64 ones in the network prefix. There are no subnet masks in IPv6. We don't use subnet masks in the same way like we do in IPv4. There's no ANDing of the IP address with a subnet mask to find the network. In IPv6, the /64 here lets you know that the network prefix is 64 bits long, and that defines the network. So here is a global unicast address example. I just made this up, by the way. So you have here /64. That means this is the 2001 2EB8 ADC1 54EB network. And then this is the interface ID, or basically like the host address. Then a link local address. This is locally significant only. Every interface would need to be routable on a network, a routable address, like a global unicast address or a unique local address, and then a link local address, which is only for the local link or local LAN. And those start with FE80, and you can see it here. And the /10 defines it, that link local is defined by the first 10 bits, which is the F, the E, and then a portion of this 8. All right, let's look at the next slide. So the network prefix. The network prefix separates the network portion from the interface ID. The network prefix refers to the number of bits in the network portion. I've already stated that. So here we have a global unicast address. You see the /64. That means the first 64 bits, or the first 4 hextets, is the network. And then the last 4 hextets is the interface ID, similar to like the host address. It identifies the interface. And then here we have a /96. In this case, the network would be defined by 96 bits, and then the remaining bits would identify the interface ID. And then let's say you had a /128 network prefix. Well, that means that the whole thing is a network of 1, essentially. Kind of like a /32 identifies a single host, or a network of 1. On to the next slide. So let's break down an IPv6 global unicast address. The network portion of the global unicast address is hierarchically structured. So if we look at those first 64 bits, the first 3 bits is the IANA global prefix. So all of the globally routable addresses currently that we're using in IPv6 is just a small portion of what's the total address available space. So the first 3 bits identifies the IANA addresses that have been assigned to be used on the internet. Then the next bits, the next 20 bits up to bit 23, is the regional registry. So these numbers here would identify your regional registry, whether it's North America, South America, Africa, Asia, etc. Then the next bits here, the next 9 bits here, would be your service provider prefix. So this would be assigned to your internet service provider. And then your internet service provider will assign you your site prefix, which is between bit 32 and bit 48. This is your site prefix. So this would be your company or your organization. If you purchased an IPv6 address from your service provider, this would be your static IP address or IPv6 address of your organization. Then the last hextet in the network prefix is the subnet hextet, and then you can assign this. So effectively, it would be, okay, this is my company, this uniquely identifies my company, the 2233 here, and then I can put my own subnet using these 4 hexadecimal characters. I can assign my own subnet. Then you have the last 64 bits, which is the interface ID identifying the host or the interface on the network. Let's talk about IPv6 address compression. Let's face it, the IPv6 address is super long. It's super long, right? 32 characters is a lot of characters. So address compression is allowed. In other words, we can write this address, this is the complete address, we can compress it down to this address. Now, how do we compress and decompress an IPv6 address? It's not hard. What you do is, here's a couple of rules. Leading zeros can be omitted. So here we go, we have 0EB8, so this leading 0 can be omitted, so instead you could just have EB8, all right? And then you have 00C1 here. So these leading zeros, these 2 leading zeros can be omitted, so you just have C1. And then notice over here in the subnet prefix portion, the subnet portion, we have 0001, so that could be reduced down to just 1. We can omit these 3 leading zeros. Then the next rule is that a single instance of continuous zeros can be replaced with a double colon. So notice we have these continuous zeros here. We have 8 and then 9 continuous zeros here. So you could take this whole block of zeros here and change it to just a double colon, and this identifies a range of zeros, a range of continuous zeros. Now, if you follow these rules, you could successfully decompress this address back to the full address length here. But anyway, this is a compressed IPv6 address. When decompressing, remember there are supposed to be 8 hextets of 4 hexadecimal characters each. That will help you to decompress this address, is that you know there needs to be 8 hextets. So we know that, well, if this is easy, this is 0EB8, and we know this is 00C1, and then we know this is 0001, well, that means we have 1, 2, 3, 4, 5 hextets. That means we need 3 more hextets. So we've got 2 hextets of zeros, and then we need to add a 0 before that 3, and we've got our 3 hextets remaining. So that's basically one of the things you need to remember when decompressing, is that there's supposed to be 8 hextets total in the address. That'll help you. Okay, let's talk about another interesting feature of IPv6, and that's SLAC, Stateless Address Auto Configuration. With IPv6, essentially, a host that uses IPv6 on a network doesn't need a DHCP server to get an address on the network. And I'll return to that.
I think I understand this. And the thing that had made me want to look into it has been sufficiently written. So I think we got this. Out-of-band management is a process for accessing and managing devices at infrastructure and remote locations through a management plane separate from that of the production network. Out-of-band allows a system admin to monitor and manage servers with other network-attached equipment by remote control, regardless of whether the machine is powered on or whether an operating system is installed or functional. It is contrasted to in-band management, which requires the managed systems to be powered on and available for their operating system's network facilities. Out-of-band can use dedicated management interfaces, serial ports, or cellular 4G and 5G networks for connectivity. Out-of-band management is now considered an essential network component to ensure business continuity, and many manufacturers have it as a product offering. By contrast, in-band In-band management through PNC or SSH is based on in-band connectivity. It typically requires software that must be installed on the remote system being managed and only works after the operating system has been booted and networking is brought up. It does not allow management of remote network components independently of the current status of other network components. A classic example of this limitation is when a sysadmin attempts to reconfigure the network on a remote machine only to find themselves locked down and unable to fix the problem without physically going to the machine. Despite these limitations, in-band solutions are still common because they're much simpler and much lower cost. A complete remote management system allows reboot, shutdown, powering on, hardware sensor monitoring, broadcasting of video output to remote terminals, and receiving of input from a remote keyboard and mouse. It can also access local media like a DVD drive or disk images from the remote machine. If necessary, this allows one to perform remote installation of the operating system. Remote management can be used to adjust BIOS settings that may not be accessible after the operating systems are rebooted. Settings for hardware RAID or RAM timings can also be adjusted. What was the question? Settings for hardware RAID or RAM timings can also be adjusted as the management card needs no hard drives or main memory to operate. As management via serial port has traditionally been important on servers, a complete remote management system also allows interfacing with the server through a serial over LAN cable. As sending monitor output through the network is bandwidth intensive, cards like AMI's Mega Rack use built-in video compression. Devices like Dell D-Rack also have a slot for a memory card where an administrator may keep server-related information independently from the main hard drive. The remote system can be accessed either through SSH or a command line interface, specialized through an SSH command line interface, specialized client software, or through various web browser-based solutions. Client software is usually optimized to manage multiple systems easily. There are also various scaled-down versions up to devices that only allow remote reboot by power cycling the server. This helps if the operating system hangs, but only needs a reboot to recover. An older version of out-of-band management is a layout involving the availability of a separate network that allows network admins to get a command line interface across interface access over console ports of network equipment, even when those devices are not forwarding any payload traffic. If a location has several network devices, a terminal server can provide access to different console ports for direct CLI access. In case there is only one or just a few network devices, some of them provide aux ports, making it possible to connect a dial-in modem for direct CLI access. The mentioned terminal server can often be accessed via a separate network that does not use managed switches and routers for a connection to the central site, or as a modem connected via dial-in access through POTS or ISDN. ISDN is, what are these? ISDN? Integrated Services Digital Network, or plain old telephone service. Okay. That sucks. This mouse doesn't have middle click. Now that I know more about out-of-band, my answer was rather silly. May still be compromised by a system-wide network failure. Oh, virtual out-of-band management. What is my note on a web browser? Okay, dude. Is a majority of web internet browsers is based off Chromium? Shouldn't I say are? Via a web browser. While out-of-band management uses separate network hardware designed around the intention of Wait, I already mentioned this. Why would I have to... We're going to haiku. Sorry. Sue me. Sue me. We're going to haiku. Okay. That makes sense. Where's network appliance? What are you talking about? Technology, networking, network hardware. Oh, it's just like an object? I should have... That'd be a folder note, and then have router and have Nick in here. And then have face card. Yeah, maybe I actually do router first. Router. There we go. And then back to network hardware. We could have Guy who has chest pain. Oh, that's funny. Okay. Cool, and I also have SFP. Cool. Cool. Okay, and then networking is like the world's largest note of all time. I'll use GPT 5.2 for a little bit. It's just so slow, you'll see what I mean. What does a failure to ping the loopback address indicate? That there's something wrong with the... What? Right, I think I got this wrong last time. Hold on. See, check out how slow GPT 5.2 extra high is. Look at that time to first token, dude. Isn't this insane? And you do all that, and then you get an answer just full of, like, bullet points. It's so stupid. Like, the responses are so ugly. See, and then you compare this to something like Gemini 3 Pro, right? Much faster time to first token, by the way. Starts thinking immediately. And then look at that. Instead of this ugly, like, 1, 2, 3, 4, 5, 6, 7, 8, 9 bullet point, and then, like, not very conversational at all, it's like, oh yeah, yes. Like, I can't even read this. Yes. Yeah, basically the loopback address is virtual, so it's where the OS's network stack, not part of the physical NIC, versus the loopback address is entirely virtual, lives inside the operating system software. So yes, you could physically rip the network card out of the machine or install a new one, and the loopback address should work perfectly fine. That exists even if bullet point, there's no NIC installed, comma, the NIC is disabled, comma, the cable, like, this is such weird formatting. Dude, I hate, like, I used to be a big like OpenAI head, but like their responses are just so ugly. Like, dude. And it's cheaper too. This better response is cheaper. God. You know what? Can't I I forget exactly how this works. What does this do? Oh, it does 3 responses at once. I see. I just noticed that you could do this. Okay. But actually, hold on. Yeah, like just look at this though. Like if I do GPT 5.2 and I do Opus 4.5 and then I regenerate it. Or wait, no. See, check this out. Watch. Claude is thinking, Gemini's thinking, GPT 5.2 is still processing. Anthropic's already written its response. It's still, GPT 5.2 is still processing, dude. You got this. You got this, OpenAI. It's just embarrassing. Flagship model, by the way. Anyway, yeah, that just really bothers me. High bandwidth. For CASBs? Cloud Access Security Broker. Okay. Right, because failure to ping loopback address specifies. Because even if there's no NIC installed, there will still be a loopback address. the answer was in the question. I think I remember getting this wrong in the past. And then I think I asked this exact question. From other ables. I hope it knows what I mean. Ugh, that's irritating, but okay. TLS handshake. Of our day 11 connectors, I mean, that's just the nature of TDM. It's not really a T-carrier thing, right? Or I guess that makes sense. Layer 3. Dude, it's so over. Because layer 3 is data, layer 2 is data link, and that's the MAC address one, right? What? Is my stream blocked? It's over. I guess I'll pause the music. Alas. Okay. If we keep the music paused, will it bring my stream back, or hold on? Hey, not in this car, right? Not in this car. Yeah, it says your stream has been temporarily blocked. Okay, I think I'm just gonna keep streaming, and in like 10 minutes, I'll see if it's still blocking stuff. Decides to replace a hub with an Ethernet, but at least I know to not use that album when I'm when I'm doing it. Replace a hub with an Ethernet bridge to improve network performance. Is that like a copyright strike? No, right? Oh, looks like the stream's unblocked. Okay, so we're fine. Okay. During a network upgrade, replace a hub with an Ethernet bridge. An Ethernet bridge is a synonym for a network switch. So you should see maybe an increase in the number of broadcast domains, but I don't think that's true. I don't think it's a number of I don't think it's an increase in the number of collision domains. Because by nature of an Ethernet bridge, it's not like a collision. I don't think it'd be a reduction in security. I'm gonna go for 2. I don't think it's correct. What does this mean? Number of collision domains? Sure, I see. Okay. So it's like semantics. Because layer 3 is IP, not layer 2. As opposed to layer 2, which is what my original answer was. I can use the restroom. Be right back. Hello all. It's actually getting kind of chilly, so I'm gonna put my jacket on. Okay. That's silly. Can I do this? Yeah, that works. Okay. A physical access control method. Oh god, I remember this. I remember this exact question because, like... I think it is silly. Bro. Yeah. Okay, sure. Yeah, it's not 1, it's not 4, it's not... Yeah, it's just 3. That's the only one it could be. Due to an increase in foot traffic, ask their security office to employ equipment that will allow cameras, duplex fiber deployment. That'd be TX and RX. Transmission is available with contention-based MAC system used by Ethernet. What type of transmission is available with a contention-based MAC system?
Have you ever wondered how computers send data on the network without interfering with the data from other computers? Especially if the network has a lot of computers that are sending and receiving data at the same time. I mean, you would think that there would be a lot of collisions happening. I mean, there should be data packets that are constantly smacking into each other in all that network traffic. But even though collisions do happen from time to time, especially on older networks, a technology was developed to not only help avoid collisions, but also to respond correctly if a collision does happen. And this technology is called CSMA-CD, which stands for Carrier Sense Multiple Access Collision Detection. And this is the access method used on early Ethernet networks. And when I mean early, I'm referring to half-duplex networks that utilize coaxial cable and earlier versions of twisted pair cable. Now, CSMA-CD basically works by each computer first sensing if the wire is idle, and if it is, it sends its data. therefore avoiding any collisions. But if you have two computers trying to send data at the same time, a collision will happen. And if a collision happens, the computers will wait a random amount of time and retries to send their data. So as an example, here we have a network with 4 computers, and these computers are all sharing a common transmission medium, which is a cable. And this cable must be regulated so that no computers send data at the same time, which would result in a collision. And when a collision happens, it causes data loss or data corruption. So let's say that this computer here wants to send data. So first it will sense or listen if there is any traffic on the cable. And if it senses traffic, the computer will wait until the cable is idle to send its data. But once it senses that there is no traffic, it'll go ahead and send its data. And as it's sending its data, it will listen for a collision. And if it doesn't sense a collision, it knows that the data was successfully sent. Now, in another scenario, if 2 computers are ready to send their data, and they both notice that the cable is idle, then both computers will go ahead and transmit their data at the same time. But when this happens, a collision occurs. And when the computers that are sending the data detect a collision, they immediately stop sending the data and instead will transmit a jamming signal out on the network. And this jamming signal is what notifies all the other computers on the network that a collision has happened. And after the computers receive this jamming signal, the 2 computers that caused the collision will wait a random amount of time before they send their data again. And the wait time must be random to each computer so that the collision doesn't happen again. So as I stated before, CSMA-CD was used on early Ethernet networks, and it isn't as relevant today due to the advancement in network technology. It was only relevant in the older half-duplex networks, where data communicates in both directions, but not at the same time. Today, we use full duplex networks, where data can communicate in both directions at the same time. And there is also CSMA-CA, which stands for...
I'm going to do a typing test really quick. Bro. Bro. Well, that's cool. 6, 7. Bro. Okay. Alright. Wow, and 49,000th in the world.
Hello everyone. In this video, we're going to talk about a couple of different transmission types that are used in networking, and those types are half duplex and full duplex. So let's talk about half duplex first. So in a half duplex network, you have a point-to-point system where two devices are connected to each other using a network cable. And these devices can communicate with each other in both directions. But in a half duplex, they can only communicate in one direction at a time. They cannot communicate in both directions at the same time. So if computer A is sending data to computer B has to wait until computer A is done before it can send data to computer A. So data flows in one direction at a time. The two computers have to take turns when they send data to each other. So half duplex is just like how walkie-talkies work. With walkie-talkies, a person has to press a button if they want to talk to transmit their voice to the other person. And while the button is pressed, information is only going in one direction. So they can't hear the other person while they're transmitting their voice. They would have to release the button in order to receive the other person's transmission. Now full duplex is better. In a full duplex, the two devices can also communicate in both directions with each other, but the difference is that they can communicate in both directions at the same time, which gives full duplex an advantage over half duplex. Devices can send and receive data simultaneously. So as a result, because it sends and receives data at the same time, a full duplex system has double the bandwidth of half duplex. A good example of a full duplex would be telephone communication. When you talk to somebody on the phone, you can talk to and hear the other person at the same time. So you don't have to wait to do one or the other. You can talk and listen simultaneously. So as a comparison between half duplex and full duplex, you can use an analogy of cars on a highway, where you have cars that travel across an area. So in a half duplex, the cars would all have to share a single lane on the highway, and that lane only allows traffic.
What? Okay, wait.
Stands for carrier sense multiple access with collision avoidance. Now this is the access method out on the network. And this jamming signal is what notifies all the other computers on the network that a collision has happened. And after the computers receive this jamming signal, the two computers that cause the duplex networks, where data can communicate in both directions at the same time. Relevant in the older half duplex networks, where data communicates in both directions but not at the same time. Today we use full duplex networks, where data can communicate in both directions at the same time. And there is also CSMA-CA, which stands for Carrier Sense Multiple Access with Collision Avoidance. Now this...
Am I silly? I
today,
don't
we use
understand
full duplex
why...
networks, where data can communicate...
Why would CSMA-CD not be necessary? Maybe I'm misunderstanding the difference between half duplex and full duplex. I see. Okay. So collision is really only a problem in half duplex because collision is only really a problem in half duplex because on half duplex only one device could be communicating at a time because like if there was something sending or receiving on another device it would just collide and it wouldn't work properly. Okay. That makes sense. Okay. to serve as a type of password. And locks on doors, even though smart cards is an access control method. And then that would be half duplex. That makes sense. After connecting the workstation, you find that you can't get an IP address from its DHCP from the DHCP server. I don't think the default gateway would have anything to do with the DHCP server, because if they're on the same LAN, it should just be fine. Like the computer would send out a broadcast to look for a DHCP server. Incorrect VLAN assignment would also be weird. I mean, I feel like these two are kind of the same. Because, like... Well, no, because even if the VLAN was assigned properly, it would have to go through the default gate. Well, no, there would have to be a DHCP relay. I don't know. Maybe switching loop? That's the only one that doesn't seem... I feel like everything else is contingent on other things happening. Incorrect VLAN assignment. Really? Yeah, okay. Right. Okay, that makes sense. Just the presentation layer in terms of data compression and encryption. I don't think the presentation layer handles routing, so I don't think it's 3. I don't think it's responsible for physical encryption, so I don't think it's 4. I feel like it's either 1 or 2. I don't think it's involved in a logical organization, so I'm going to go for 1. Universities, computers, isolated, allow controlled access, put it in a VLAN. Okay, it's not 2. It's not 1. 28 maths. Why can't you rely solely on the first 3 octets? Because, yeah. The software-defined network. That's what SDN stands for, right? Software-defined network. Yeah. Transport agnostic? First step in a DHCP release process. So that would be the host sending out DHCP discover packet. A network engineer is tasked with optimizing data transfer between a data center and remote office. Includes various network differing MTU capabilities. That's maximum transfer unit. Right? Maximum transmission unit. When the transfer rate is lower than expected, MTU mismatches. To address this issue, what should the engineer take first? It's not 3. One and 2 is just like 1 and 4 is just like randomly doing like bullshit. So I think it's got to be 2. And then that would be incorrect VLAN. Okay, you got me. Okay. What is the role of threat research? What subnet mask would you use? That would be 4. Common consequence of rogue devices. Purpose of using physical network diagrams. What is the purpose of checking local name caches? When troubleshooting name resolution issues. Are communications between VLANs facilitated through a IP router or layer 3 capable switch? What is one solution to mitigate the risk of rogue access points? I'm not sure. Mutual authentication sort of implies that you're also authenticating the access point. So I feel like it's probably 4, yeah. Oh god, this one. Capture only ICMP packets. Would that be any ICMP? Yeah. A network engineer at a medium-sized company has recently learned about VLAN hopping attacks and is concerned about the security of their network infrastructure. The company's network includes several VLANs to segregate different departments for security and organizational purposes. Might attempt a VLAN hopping attack using the double tagging method. How can an attacker successfully execute a VLAN hopping attack using the double tagging method? Why might it be necessary to adjust the power level used by an access point on a given channel? It's not 2. It's not 1. What? Oh, I thought the first part here said that I thought this said to ensure the access point can interfere with other cells. But turns out only this one has this, so that's why I counted out 1. And I was like, 3 looks the most correct, but actually 1 looked the most correct if I had read it properly. Which option can be added to the dig command to reduce the output by removing comments from the results? Dig is like the only piece of software that has pluses for some flags. Is it plus no comments? That's so crazy. In IPv6, what does the network prefix of 48 indicate? Which networking function or device is associated with the transport layer of the OSI model? The transport layer? Which tool is used to terminate fixed cables by fixing conductors into an IDC? That'd be a punch down tool? I kind of wish it didn't tell me what I got wrong, just like that I got something wrong. So then I have to think about it more instead of just like remembering which one was the correct answer. What is the role of a direct connect link in cloud connectivity? Direct connect link. Oh god. For your company's wired network, you want to ensure these devices. You also want to implement a system where do not need to be stored on network switches, but can be validated by a server position in a secure zone within the private network. You manage a network that is connected using a physical star topology. One of the drop cables connecting a workstation has been removed. We're in charge of planning the entrance facilities for the structured cabling system. Okay, wait, what? Your company is expanding its operations to a new building that requires a complete setup of its network infra. You're in charge of planning the entrance facilities. The goal is to ensure the new setup allows for seamless integration with external telecommunication services and supports efficient inter-building communications. What is the primary purpose of designing the entrance facilities? Doesn't it just say above? It just tells you what the answer is, and then it asks you what it just said. God. Help desk operators troubleshooting a site that is no longer responsive. What? Oh, the last step. I thought this said first step. Whoops. Why is plotting data as a graph helpful in log analysis? Yeah, document findings. Whoops. Whoops, I didn't read the question properly. Common story. going to be a source of internal threats? It's the release, right? Channel link referred to in the context of Ethernet connectivity. Okay, sure. Yeah. I remember that. What is the purpose of creating a new plan with marked basic service areas and associated APs during a wireless survey? What? Under what condition can an organization process credit card directions if they adopt the PCI DSS? Which of the following methods provides thermal performance, improves the thermal performance of PoE cabling? What technology is used to connect the customer's premises to the satellite internet service? VSAT. You're setting up a new server for your company, Widget Innovations. Awesome. Which hosts name, that'd be docs.widgetinnovations.com. Cybersecurity analyst, analyzer, moderator stance. 6 consoles, 10 computers, bunch of fucking wires. Okay. Cybersecurity analyst, data exfiltration. Any current or recent connections? Oh god, I think I'm gonna get this wrong. Okay. That was lucky. Can IPAM software scan IP address range? What is IPAM? IP address management. Scan IP address ranges to detect the use of statically assigned. Yeah, probably, right? Because it could, I believe the answer is yes, it can also scan hardware. What? I meant to press 1. Sorry, guys. You heard me. You heard me say the answer, and then I pressed 2. I meant to press 1. Sorry. That's embarrassing. Yes, it can also scan hardware. God, whoops. What feature does version 2 of HTTP add to enhance its functionality? Yeah. Which of the following security appliances operate at layer 4 of the OSI model? So it's physical data link, physical data link network transport. So transport, that would be what? Well, aren't some... I answered this because some network switches are layer 4, right? Yeah, okay. I only saw this because I saw network switch and I was like, oh, layer 4, right? But I guess, you know, most network switches aren't layer 4, I don't think. And I guess it is true that firewalls and IDS is like mostly a layer 4 thing. So, global configuration mode. It's something weird, isn't it? I don't think it's 2 or 3 because that would make too much sense. It's either like enable or configure terminal. Okay. um, what is Enterprise Mobility Management Suite? Purpose of using TLS transport encryption in databases. That was a stupid... All of the... I stared at that question for a while because I was kind of daydreaming, but only one of those answers is obviously correct. Can the same domain name be registered within different top-level domains? Yeah. That makes sense. Doesn't it depend on if you're using Linux or Windows? Though on Linux, I'm pretty sure it is on Windows. I'm pretty sure it is the words trace route, while on Linux it's trace RT. And so on Windows, I think it uses ICMP. Really? Does it use UDP? Am I thinking the other way around? Oh. Okay, I was thinking of it the other way around. Whoops. Primary function of a gateway in a VPC subnet. Boom. An IAZ. Anycast addressing. I don't think it's two. I think it might be one, because Anycast... Yeah, okay. IP spoofing can't be sent back to the... Well, not... Yeah. And then trace route, it uses UDP, because on Linux, trace route is UDP. On Windows, it's trace RT, and it uses ICMP, so... Yeah. That isn't what I meant to do. For the router? Really? What? Narrowband? Dude. I see. Okay. That one was kind of obvious. Okay. Be right back for a little bit. Oh God. I don't know. 12 and a half? Okay. 8.3. Okay. Which command can be used on Windows to display the fully qualified domain name of the local host? Oh, wait. Oh, okay. I see. So it's just out of band without the phrasing. I see. That makes a lot more sense. Telnet. Um, now look at this net that I just found. When I say go, be ready to throw. To implement overlay networks VXLAN, 8.3. And then private server administrative network, because it's just talking about out-of-band management. Maximum theoretical size of an IPv4, isn't it? Oh. Wait, what am I thinking of? Oh, I'm thinking of an Ethernet frame. Whoops. And this makes a lot more sense. And it's actually, you would think it's 1518, right? Because... Hold on. Oh well. There's like a... I don't know. Never mind. I guess that makes sense, because it mentions segments in the question. I see. The main difference I remember between STP and RSTP is that RSTP is really fast to like do the switching. And so I think STP outages last tens of seconds, and then RSTP they're like a couple seconds, and so that's like the gambit. I don't know why I said that, but that's like the main difference. And so when I saw like answer referring to how long the outages lasted, I answered that one. But this one makes sense also. Yeah, because I do remember RSTP does have. Okay, sure. I think RSTP has less states. Um, It's either 2 or 3. Because that's how binary works. This isn't necessarily true. Manually configure the network connection. Is that just like SSID and password, or is it like the network settings, like your subnet mask and your default gateway and such? I don't think it makes the network invisible because that implies it doesn't work. I'm gonna go for this one. Okay. What is an extended service set? Okay. Non-graphic, so not Wireshark. That'd be Netcat? ngrep, right. I forgot about ngrep. Because UTP stands for unshielded. was doing something on my right monitor. Sorry, everyone. I'm going to use the bathroom one more time. Okay. Wow, alas. Oh, I meant to press 2. Sorry. God. I know you're not supposed to ping the default gateway. You ping the loopback address to see first if there's like something wrong with the network stack in the computer. You would, then you do the host IP address, and then you would do the default gateway. Sorry, guys. Sorry. The network layer of the OSI model to authenticate hosts and encrypt packets. Would that be to authenticate hosts? Would that be IPsec? So rollover resolver. 0 day. when addressing wireless coverage issues. Bro, what is happening? This is gonna be so expensive. What's the TPS here? Dude. 39 seconds of thinking. What's that, like? A 3 sec. Okay, that's not bad. I see. Okay, that makes sense. I mean, can't you not connect to Stratum 1? Can't you? Don't you have to do Stratum 2? Okay, my bad. Okay, I was planning on studying until 2, but we only have like 100 questions left, so I might just be done studying now.